Okay, so now we're going to look at, I've decided I'm going to go to pointers, and then I'm going to go back, and not pointers, excuse me, arrays, which is an easy concept, but I want to show you arrays of objects as well, and introduce the concept too of arrays, and then we'll make some arrays of objects, and then we'll go into a little bit of inheritance, and then I'll mix in a little bit more constructor stuff for you. So it mixes it up a little bit for those people who are getting bored, if you are getting bored. so I'm going to start out with, and if you go into miscellaneous examples, this is the one we just worked on, which was lecture number 3, which is day 2. If you download it, it's day 2-3. I don't know why I labeled it that way. The labeling got a little confusing for some strange reason. It's this one here. It's the number 3 is the one I'm going to pick up with. There's also, again, the source code for 3A and 3B, which is the other stuff I just did in the morning here, which is the single files one with the pointers. I think 3B is the pointer. Yeah, we got the pointer stuff in 3B. And then we get the picture that goes along with 3B, and then so there's a method to this, and then the source code for 3A, and then the picture that goes along with 3A. So we have both of those two pictures in there. So, all right, so we are going to start now in with the concept of arrays. So open up the one lecture 3 source code, or start with what you left off with. Or just open up, what I did is I opened up the project that had the dog and the person in it. I know the theme's getting kind of old, but, I go into main and just remove everything in main except for the get to character and the return at the end. And what I want to do is kind of explain to you the concept of arrays, because this is a concept a lot of people don't understand to begin with, and also talk about strings, arrays, and arrays of objects and stuff like that. Alright, so I'm going to push this all down to the bottom. I kind of wrote some stuff ahead of time so I didn't have to worry about typos. We're all familiar with this one by now. It's integer I. I don't believe I have an I throughout this entire source code. No, I don't. I is just one integer. It is one integer value for us. If I want to make 5 I's, I add an index on there next to the name of the variable to say that I want 5 of them. So the structure is the same. Here, I can put in 5 as an example, and now I have 5 I's, which is an interesting concept. So how, let me make sure I compile correctly, and I do. So how am I going to know, well, why do we have 5 I's? Well, because I can store now 5 values. I'm going to comment out this code, because when I start running it, it's gonna do a bunch of stuff. And give me 2 seconds here as I comment out this code. Yep, there we go. We're going to get to that in a few minutes. But, okay, so if I see out an I literally, actually here, let's make this B, and I'll go integer A. So integer A is a separate one integer, and integer B is going to have 5 integers in it. We know already we can see out. If I see out, I can just put A in here. And then I get A printed out to the screen. And in order for me to do that, I'm going to have to say, well, let's go A is equal to 1. And if I do that, I'm going to get the number 1 printed to the screen. Make sure, what have I got going on here? Oh, probably this is going on here. Hold on 1 second. Back from lunch, I have to restart over again. There we go. I was just in the groove. Now I got to get back into it. All right, so if I see this out, I have 1 gets printed to the screen. So imagine that's what we would expect, which is great. Now the big thing comes in handy. It says, well, how do we assign values to this? So this one was easy. I just said A is equal to 1. It's just one value. If I did this, if I go like this and go 1, I'm going to get in trouble because it's not going to know, well, which one are you talking about? But unfortunately, we have this little cheat sheet method in C++. If I do this, put curly brackets around it, well, then it's going to assign 1 to all of them, which is interesting. So if I execute this here, I can print this out. But if I print out, as an example, B, I'm going to get the starting address where B is located in memory. I'm not going to get anything. B, the name of the variable represents, it's like a pointer, which is why I like to cover arrays after pointers. It's the starting address in memory. So if we look at that and I compile it, it'll work just fine. B is a valid B is the name. B is the name of the second one I created. But when I run it, I'm going to get X22 something or other. And it's a hexadecimal address. It's a memory address. So anytime you see something that looks like this, that's a memory address, which is great. So if I want to have a consistency here in terms of what I'm going to print out, I want to print out the first element. So arrays start with 0. So if I have an array 5, I've got 0, 1, 2, 3, 4. It doesn't go up to 5. 5 is the number of elements in the array, indexed to start at 0. So if I want the first element of the array, I specify the index value using this bracket notation again. So now I have B0. B0 is going to print out 1 because I assigned everybody to 1. What if I don't want to assign everybody to 1? I can do this. I can say as an example, B0 is going to be equal to, well, let's make it equal to 0. And then B1 is equal to 1. And B2. I'm only going to do 2 of them here, or up to 2. It's equal to 2. So now when I print out B0, I should get 0 printed to the screen because I'm using the index values here of the 0. So I'm going to get this one. So if I'm going to print it to the screen, I'm going to see 0. And then if I say, well, I want the first element. The first element is 0. Well, I want the second element. The second element's 1, so I print out 1, change it to 1. And now I'm going to see 1 printed to the screen. 1 printed to the screen. So the only thing you have to remember with arrays is they're just like any other variable and also just like any other object. The only difference, however, is that you have this opening and closing bracket, and in that opening and closing bracket you're going to put the size of the array. So now there's a little trick here. You don't actually have to specify the size of the array. You can leave the array empty if you want to and have the memory, have whatever you assign to it, specify the size of the array. So underneath I'm going to go integer C, and I'm going to leave it blank, but I'm going to have it equal to a set. I'm going to have it equal to a set of 5, 10, and 20. Let's make sure my syntax is correct, and it is. This set starts out with opening curly brackets, ends with curly brackets. If you've used this here, which is my intuition, when to do that is wrong, you're going to have a problem with that. So the set wants to be opening curly brackets. So now I have 5 integers, so this array size is going to be 3. It's going to be 0, 1, and 2. So if I wanted to, I'm going to go down here and I'm going to change this one to C, and I want to print out number 1 because I want 10 to show up on the screen. So I'm going to print out number 1 of C, and so now I'm going to get the value of 10 showing up on the screen when I run it. So I got 10 on the screen now. So I'm getting at each one of the items through the standard index of 0, 1, 2, 3, 4. And then it doesn't work with, it works with more than just integers, so let's try a character. So I can do the same thing. Actually, I'll just change this here. Well, no, I'll put it underneath. Character. And I'm going to call this S instead for a string. Let's just use it. And I can use the same technique. I can go equals, and then I have to give it a character. So there's an A, B, C. Oh, let's put a D in here too. D. So now I have A, B, C, and D in there. Make sure it's correct. It's correct. So I can do the same thing. Now I go S. I'm going to press that S1. Oops, that's a B. I've got 2 A's in there. So now I have S1 should be, I should expect to see B printed to the screen. So I'm going to go ahead and run it, and I have B printed to the screen, which is pretty cool. What if I just printed out S though? If I print out S, I'm going to get printed to the screen. A, B, C, D. What's this funny character? Let me zoom in so you can kind of see. It looks like a spade or something. It's a null character. What does that mean? Well, alright, so strings and character arrays are the same thing, and we have an exception. So, okay, so they call this a lack of orthogonality in the language. And also, I call it an inconsistency in the language. C is one of those weird languages with all these inconsistencies. As I mentioned before, if you print out I, an integer, you're going to get the starting address going to be a hexadecimal number. If you print out a character array, or you print out a character pointer, you're going to get the entire string. If you do a string, you're going to get the string. So let me talk about string for a second here. I have string included. So we'll just leave this one for a second. Just remember when I printed out this entire character array, I got A, B, C, and D. I got it all. Actually, did I get it all? A, B, C, and D? I don't know. I got most of it if I didn't get it all. I got more than what I expected. If I print out one of the individual characters, I got what I expected. So what's the difference between this one, character, actually I have it down here. Let me cut and paste from down here now. Let's see. So I don't have to copy, I did this ahead of time. It's filling in up here now. It's going to take you longer to copy it, to write it, but alright, so now I have this line of code here. Remember what I just said about arrays? Excuse me, what I said about pointers, and I said about character arrays, and I said about all sorts of different things in terms of pointers and how the memory addresses are stored with the name. If we take a look at this as an example, here is a character pointer. So I created this pointer here. Let's just look at this line right here. Character pointer first equals Barbara. If I see out here first, I'm going to get the word Barbara printed to the screen. So I'm going to remove this here because I don't want this one to print. I just want one thing to print to the screen. So I'm going to see out first. I'm not going to get the memory address like I thought I would, like I just told you I would. Oh, there's no S anymore. I took the S out. I commented it out. So, let's see. But I have the whole word Barbara written on there, and I don't have anything. I don't have any null characters or anything. No garbage printed at the end of it. So before we had the string class, we had this. This is the replacement for the string class. It's the same thing. So string, when we include the string library, we don't need to include the string library for this. This is what's called a character pointer, but it's really an array. So a character pointer, a character array, and a string are pretty much all the same thing, and they can all be used the same way, which is way inconsistent because you can't do this with an integer, you can't do it with a float or double, you can't do it with anything else. This is like way inconsistent in the language. However, that's one of the things you probably want to be aware of, because then you don't have to do things all the same way. You can switch things up. What do I mean by that? Well, if I did this, let's just put a string underneath here. I'm going to call it string at S first. So S first is the string interpretation of it, and I'm going to put here Barbara Hecker. I'll put my full name out there instead. Now what I can do down here is print out S first now, and if I do that, I'm going to get an error message because I haven't string is initialized. Oh, can't do it that way. Nope. Take out the pointer, by the way. Okay. Can't do it that way. I can't make a pointer out of a string. It's already a pointer. A string, it's a reference to a reference. That's what that is. Because when this is what this is referring to. So when I say string, this word here, string, is equal to character. All I'm doing is using this word instead of this syntax. I'm just using different syntax. I'm getting the same thing. So the string is the character pointer. But the character pointer is also a character array. I'm going to show you that in a few minutes. So now I've got this string S first, and I'm going to print out S first to make sure that it works. Just to make sure I'm not doing any typos here. And lo and behold, I get Barbara Hecker printed to the screen. So I go, well, this is interesting. You just said it's also a character array. Well, show me how that works. Well, up here, remember I made this character array up here, character S, and in S, I didn't use a pointer. Although I could if I wanted to, but I didn't use a pointer. Instead, these are just simple characters. This is a string. This is a character. Isn't this supposed to hold one character? Yeah, it's supposed to hold one character. It's one single character. So that's why we put the character here. Character is one single character. It looks like this, but we assigned a string to a character because we put a string in the space that a character belonged into, and it expanded past that leaf, which is not so safe, but it works. But did you see the garbage that was on the end of that string? Or maybe it was a null character. It looked like a spade, actually. You're never going to see a null character being printed out there. Sometimes some of the compilers will put a null character. What do I mean by a null character? Because we're spanning out as long as we want to go, we don't know where the end of that thing is. And if we want to read the whole thing, they have the symbol here. That is it a /n? I think it's a /n, which is because the other one's a line return. Which, is it \n? No, that's a line return. No, this is a line return. No? That's a sequence. Anyway, I get the backslashes messed up. It's either that one. I think it's that. Or is it the other way? Yeah, but that's for printing a new line. It's the opposite of print new line. I think it's that one. So you'll see in the memory, you see this written. You append it, and I don't know, it doesn't ever print to the screen, so I really don't even know what it looks like. And you can't put it in there. It doesn't work that way. Actually, it might be this. It might be 0 or O. That's a /O probably, and it's probably this /O gets put in. That's probably the null character. Long story short, it's a sequence of ASCII characters that signifies that we are at the end of, is it \0? That's it right here. Probably right. Okay, so I guessed it correctly eventually if I stumble upon it. Long story short, it says this is the end of the string, don't read any further. So the string library puts this onto it automatically. So technically I should get it, actually. If I looked inside of that memory, I should see it on there. So that's one of the things string did for us. But let's take a look here at the, see if this is 0, 1, 2, 3. Let's look at 3. We're going to get a lowercase b. So we can go like this and go 3. And we can print it out. And we see, lo and behold, a lowercase b that gets printed to the screen. Well, that's a string. So it's also a character array. It's also a character pointer, which is interesting. So if this is 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's try number 14. Let's see what's at number 14. So if we print at number 14, we don't get anything. So that's why I say you can't see the null character. It's not going to print on the screen. It's there, but it's not like human readable. It's in the memory. It's there for the computer. When you print it out, you're always going to see just this. You're not going to see the null character at the end of it, but there is a null character out there. So if I went to, let's say, 15 or 16, it's dangerous. I might get garbage. I might get nothing. Depends on what's out there. If I keep the computer running long enough, oh, here's a C. That's an interesting character. Where'd that come from? Yeah, it's just out there. It was out there at space number 16.
Would you print 8?
Print 8? 8 characters?
Yeah, yes. That's good. Number 8, that's good.
That's what you want? It's going to be a blank space probably, or what is it going to be? It's probably going to be a blank space. No, it's H. It's H.
So 7.
7 is going to be a blank space probably. If it's right before, if it's right here,
Yes.
that's probably going to be a blank space. Should be a blank space. There's a blank space. Yes. It's blank. So this is really equivalent to, in fact, I didn't do it. Let's do it. Let's see, right underneath it I'm going to go character. Why don't we make this my name? And we have it equal to, ooh, do I need to put the quotes in for that? Probably not. Let's see if this works. It does work. That's good. These two are equivalent. So if I did this and printed out my name, I'm going to get the starting address here, but we don't know what length it is until we get to the null character. Then we're going to stop printing it. Are we going to have a null character? Well, that's the interesting thing. Let's see what gets printed out. It gets printed out the same way. So it's equivalent in terms of its implementation. So what you're looking at, if I made this one hecker and then print it out first, that looks like pretty good too. So we got 1, 2, 3 different ways of pretty much doing the same thing that all work. So that's why I call this inconsistent. And it's not inconsistent. Let's just say that it's optional. You can do anything you want with it. If I do the S here, that wasn't stored as a string. It was stored as a character array. I remember I put A, B, C, D in there. I see A, B, C, D, and then I get this really weird character at the end. So this one here is a character array. These are string arrays. Well, what's the difference between a string and a character array? If you do it this way, you get garbage at the end. You got to go -1. So it's not, it's thinking that there's a array index at the end there, but there isn't. It's not going to give us the same output. It doesn't put the null character. These guys put null characters at the end. This one does not put it. So no null at end. These guys have nulls at the end. So these guys print out nicely. This one doesn't print out. But can you use it the same way? Yeah. And can you use this like that? Sure, why not? So, and here, even with this first here, or which one did I just put in? My name. Well, my name's no brainer. My name 0 is going to print out a capital B for me. Should print out a capital B. There's the capital B. So. That's a raise. There's a raise in 5 minutes. Okay, so you got different choices, yes?
What did you put in that first character array, S1?
S.
Inside that array, press with 4 and 5.
Oh, I can put 10 in here.
So
It'll make the rest of them.
Show the null one.
Let's see. Let's change this one to S. Oops. So we're going to print out S as 10, but I only got 1, 2, 3, 4 in here. I only have 4 stored, but it thinks it's 10 long. And now I got 1, 2, 3. Well, because it's blank. It's blank all the way up to 10, actually. For the same reason that this works. If I go up here and say, okay, so if I do this, it'll initialize to this. It creates 10, but puts blanks in for 1, 2, 3, 4, minus 10. Six spaces in there have blanks in them, which is interesting. So I made it one. If you make it one bigger, you got a blank instead of a null, which means you can't use it in a loop, but you can use it anywhere else. Which reminds me, I should show you for loops with arrays. If I do this and go, let's say integer a, let's go back up here, and I say let's turn a into an array, and let's make it 10 as well, and let's have it equal to 0. What I did is I just assigned all 10 entries 0. So if I print it out, if I see out, actually here I'll just do it, I'll do it down here because we're printing out something. If I print out A5, I should get 0 printed to the screen. There it is, 0. I can do the same thing like this. I can go, well, I don't want it to be 0, I want it to be 9. This works too. It just takes the number and puts it in for each one of them, so now it's not. Now it's 0. A5. Well, actually, it initializes them to 0. Let's do this. 1, 2, 3, 4, 5. Let me just try something out here, actually. I know I didn't put 10 of them in there. Oops, I don't want to abort it. I want to compile it. I probably should just hit compile and run, actually. Now we got 9. The rest of them, if I do, what do I got? 1, 2, 3, 4, 5, 6. Numbers, well, just pick something higher than this, like 8. Number 8 here. Number 8 should be 0. So the default value for the data type, so if it's an integer, it's 0. If it's a float, 0.0, double 0.0 character space, whatever it happens to be. It'll only, when you do 9, it'll only set the first one to 9. If you do 0, it sets them all to 0, actually. Or if you do sum, it sets the rest of them to whatever it needs to be. You can also do this and dynamically set the size. So I've got 1, 2, 3, 4, 5, 6. So I can come back here and print out 7. And I've got them set to 9. So if I print out 7, well, that's past the array. I'm not going to get it. I got an 8. Well, where did the 8 come from? It's just this random 8 that's in there. So that's the weirdest thing with arrays. You can actually read past it. Watch this. So I showed you how to initialize them. And these are just a couple ways. What you're going to need to do is practice initializing them in different ways. The easiest way to do it, and I'll just start back over here from scratch again, is just to take it and go, well, I want an array, I'm going to call it A, and I want 5 of them. And then you can go A1 or A0 equals this, A2 is equal. So I can do this here. This is the tedious way of doing it. To 1, or to 6. Well, let's just go 0. Well, let's go 0. And then here I'll cut and paste because I'm bored. Paste. 1. Paste. I'm going to make this 4. Through 2. I'll just do it. Paste. 3. So this is 1, 2, 3. Well, let's make this one only 3. I have an extra. If I have 3 elements, I have 0, 1, and 2. 0, 1, and 2. This guy is extra. Let's see if he works. So over here, and then my cout. Where's my cout go? Here, I'm going to move this up a little bit. Let's print out A3. Let's see what happens. It should be 3, right? But the array is only defined as there is no A3 in this. There's A0, A1, and A2 for 3 elements. So remember, this is the number of elements. So we have here 3 elements. And I got here 1, 2, 3, 4 pieces of data defined. So I'm 1 too many on this concept. So I'm going to print out the 4th and see what happens. And if I print it out, I get a 3. And I go, wow, that's fantastic. It works fine, right? I'm all ready to go. This is the worst part. That's exactly what I wanted. Well, there just happens to be nothing over there. We wrote past the bounds of the array. Compiler never caught it. Didn't give us an error message at all. And it printed and it worked just fine. Actually, I thought it would. So let's change it now. Let's change it to 7. Let's change it to 8. So let's see what happens. It probably will work as well. It's unpredictable, however. We got lucky that it actually worked. Look at that. It says 8 on it. Do I have this set correctly? 3 elements, 0. Let's put here. No, I'm not happy with this. Let's make this 2 elements now. So now we're going to define it as 2 elements, and I've written completely past it. I still got 8. Woohoo! It's what? It's updating itself? No, it's not supposed to. Upgrading? It's picking out garbage. I put 8 on there. It's actually working, which is interesting. If I say that, unless am I printing out A? I'm printing out A. That's correct. Let's do A19. Huh?
Is it possible to print the size of the
Yep, we can do we can do a size on it. What is it? Size? Length? Size of? Size. Let's see if size actually. I think size would actually work. Let's see. No. Size in A, which is not classed an integer 2. Request size of. Is it size of? Yeah. No, that's going to give us our bytes in size. That's not going to work. Size of A. Is it size of A? It's a function call, not a method. Size of A. I don't think that's going to work. 8. No, it's not. That's not going to work. Let's see. How can we make this fail completely? Let me try this here. Get one element. I'm going to go A19. That's way past the one element we put in there, right? I just want to see garbage to the screen. Whoops. Hello. Execute. 0. Let's try this. P. P only has one element in it. One element. P0 is the only thing that's supposed to have a value in it. And I'm going to print out P3 to see if 8 goes to the screen. You know what? This is probably going to work. I'm sorry? 12. Alright, it's not supposed to work. Yes? Character? Yes? Because it's compatible. This will work. Well, so will this. Character, another first. They'll both work because, oops, that's not going to work. Character and type character from character to character, character first is a string array. Character. I can't give it a value. I have to give it, like, I have to do this with it. I'm assigning a pointer a value. So here I'd have to go follow another first, have it equal to A. To store a value in there, I have to actually follow it to have it stored. This is working this way, and this is working this way because of what I was saying before. It's inconsistencies in the implementation. So the exception to everything are the characters. The characters are treated like strings. Imagine about 20, 30 years ago we didn't have string. We just had characters, and they had to make it work. So they modified the character to make it compatible with a string, and then the string compatible with a character, and then they did the whole character array thing, and then they transformed it into string, and the string is just a character array, and vice versa. So they made up this brand new data type string that wasn't a primitive. Character is a primitive. But before they invented string, they invented all these other workarounds so that you can create a string from a character. So it's very inconsistent. You can't do this with integers. If I did this, you know, if I did, let's see how this stuff works. So let me go under here. If I did let's just do float here. No, let's do integer. Integer, what are we going to do here? That pointer, and we're going to say my int. This is the same thing I just did with the, oh no, let's do it up here. Just like this one here. If I did this one and went equals, well, I can't. It's supposed to be equal to a memory address. I'm going to have the same problem as before. What will happen with the address of first? the address of first. It's going to get a type I'm going to get a type mismatch error on that because actually I can't do that. Let me just do it underneath here. My int is going to be equal to the address of first, and then I'm still going to have problems with it. Oh, here it is. Cannot convert character to integer in assignment. But that's not a character either. That's a string. So it's a inconsistency. It's the only way I can describe it. There's no rhyme or reason to why it works outside of the way that that was just implemented that way. So let me get rid of this because this is going to have a problem. And let me go back up here. So yeah, technically it's not supposed to work. You're writing past the bounds of the array. You're not supposed to be able to write past the bounds of the array. It will get you in trouble eventually. Unless dev has some workaround for it that's automatically creating it of the right size. If I go P1, it's dynamically allocated. I only get 1. I'm not supposed to have 3 in here. So if I have short on memory, I would be writing over something that already existed. Okay, so to assign values, this is an example of assignment. To get the values, this is the example of getting the value. So let's take this a little bit further and start looking at arrays of objects, which is the more interesting part of this. So, let's see, that's what I just did a few minutes ago, the whole element 2, element 1. Here's actually, let me do one more to show you the string and how the string is treated like, I don't know if I did this already, but I took a string here and put my name in it. I did the string here. Yeah, did I do this part here where I just pick one element out of the string? If not, here's another way of doing the string. What I've got is the second element from here, which is going to be 0, 1, which is going to be, let's see, when we run it. Ooh, finally it corrupts on me. Because I've got more than one array going on and I probably loaded them sequentially. So finally I'm getting an error message that's going to occur because I'm writing past the bounds of that array. I'm actually writing into this next one. So I can fix that error real easily by taking off. If I only have one element, I only have one element. So let's just take these guys off. I can still print out the third element. I should be able to still print out the third element. Let's see what happens. Ooh, can't print out the third element. What did I do down here? Maybe I did something else in another instruction. But you see, I'm getting code that compiles perfectly, but when I run it, I'm getting exception, application errors, something going on. And this message isn't going to be, it says the memory could not be written. Click OK to terminate the program. Alright, so I'm going to take a look here to see what's going on with my memory. Well, let's just take this one, take this out. And I know it's not string whole that equals Barbara Hacker. That looks pretty correct to me. And I got a whole 1. Okay, that looks pretty good. So now I'm getting element 2, which is A. I don't know what this is up here. What am I printing? Oh, I'm printing out this guy that doesn't exist. Where's my other C out? It must be at the top. Let's see what's at the top of this code here. C out P3. P3 is doesn't exist. Now it's 20888809 something. So now it decided to work. So now I'm going to come back here and we have working code. I'm going to just remove that in there because I don't like that example. So let's see what happens if let's say, so we're getting interesting stuff printed out. So this one here should print out the correct number, which is P0. So I have 0, and then I have the second element. So now let's take and overpopulate this. And then we're going to notice that the error is going to come, well, the error should come back. It's not going to come back. Okay, it's unpredictable. Let's just put it at that. Let me put 20 in here. There we go. There is no P20. Here it is. That's what I want to see. Garbage. There is no P20. It is supposed to give you an error message when you write well, actually, believe it or not, when you write past it, it probably is not going to give you it's not giving you an error message. It probably shouldn't. But when you pull something out that you didn't write to, you could possibly write to something that is owned by somebody else, and that's going to give you an error message. Because what ends up happening is we have continuously allocated space in this process. So going back to that big old process I drew before, if I say I want P1, I get P, it doesn't say P, but I get one square that starts out with, that's got 1 in it. And then down here, I didn't notice any problems until I started making another one. Down here where I got this string, and I'm going to print out this string hole. Well, the string hole that's being printed out is going to be contiguously located next to P. So I'm going to start with block number 1, block number 2, block number 3, block number 4. Allocate till I fill everything up contiguously from the beginning of my memory to the end of my memory, which we don't know what the end is until we run over all of the stack stuff. Same thing happens when you run over the stack stuff, actually. You get these really weird messages that come out from nowhere. Because you're writing into memory spaces, or you're reading from memory spaces that you don't own. Because P only has 1 item in it, but you're going to come out and say, well, give me P20. I have no idea. It's a garbage. We don't know what's in P20. So, all right, I don't know what this was with B, but I'm going to get rid of B. I'm going to get rid of S down here. So we already did this one. We did this one. We did this one. We did this one. And we did this one. Perfect. So we've already seen this one with my ints. Well, let's create some pets. So these are characters and integers. Let's proceed down and take a look at this guy. In this particular case, I've created my pets 4, and they're of type dogs. So I have 4 dogs, and they're called my pets. So when I go to run something of this nature, here's an example of how to run it. I'm going to take one of my pets, and I'm going to print the age out. This is equivalent to saying something like, if I were to do my pets 4, I could go dog, D1, D2, D3, D4. And if I do that, I'm going to get 4 constructors fired. 1 for D1, 1 for D2, 1, 2, 3, 2, whatever. And if I go back and I go, what constructor is going to fire? We know from yesterday we're going to have the default constructor fire because we're not giving it any parameters. And what's the default constructor going to do? The default constructor here is going to set the age to 21 and the weight to 50. And it's going to print out in default constructor. And put an end line, that's good. Put the end of line on there. So if I take a look at what I just wrote down here, then I should get 1, 2, 3, 4 of those. Plus I'm going to get another 4. So I'm going to put here a little C out that's going to say, now for the array of dogs. So we got the single dogs being printed out. Now for the array of dogs is going to print out next. Shouldn't I see 4 more in the default constructor and the default? So I'm going to see 8 total in this example. And then I'm going to print out here pet age is, I don't need that. Pet age is, I'm going to go my pet 0. Because just like I did up here, and I said P0, P1, P2, P3, and then I run dot get age. Same thing as if I were to run this one that said D1 dot get age. It's the same thing. So instead of going D1, D2, D3, D4, I'm going to call them all my pets, but it's going to be my pet 0, 1, 2, 3, 4, or 0, 1, 2, 3, because there's only 3 of them. Or 4 of them, but it goes 0, 1, 2, 3. So 4 elements total. So now if I run it, I should see 8 messages about the constructor firing. And then the last thing on the list is going to be, let me take out this element here. It's in the default constructor. So my pets, only the default constructors are going to run, just the same way as these default constructors run. So we're going to have D1, D2, D3, D4 constructed. And what we're going to get in the default constructor, if I take a look at the dog.c++, it says in default constructor. And in the default constructor, it's going to set the age to 21 and the weight to 50. And this is the one that doesn't take on any parameters, which is how we know that one's going to fire. And so I want to get rid of these other couts so we can see the print out correctly. That one we want. Okay, so now if I run it, let me just compile and run. There we go. I got 1, 2, 3, 4 for my single D1 to D4. Then I got now for the array, 1, 2, 3, 4. I got 4 more. And then I printed out the pet age is 21 by running a get, oops, further down here, by running a get age on pet 0. Well, they're all 21 because I used the default constructor on all of them. Have I lost anybody so far? So this here is equivalent to this here. And which one's easier to locate? This is why it demonstrates also the value of the array. This was a little bit easier to keep track of all those 4 dogs. Just the same way up here, it's easier to keep track of all these P's, and this comes in handy for different reasons. This isn't necessarily so I can keep track of all the characters in my name. This is more like so I can treat my name of its 15 characters. I can treat it like a string. So I can treat them all together. So I can treat all these dogs together. So I could have people, and I can make an array of people in the same context, and then have 5 people, 5 pets, keep them all together, and then go people 1, people 2, people 3, or people 0, people 1, people 2, and go dot, get name, get age, get birth date, stuff like that. So let's say we want to run a constructor that's not the default constructor. So what we did here was we ran the default constructor. So I'm going to see out this here. Excuse me, I'm going to comment out these guys here so it makes the screen a little bit better. And I'm going to uncomment this line. Now I'm going to create 3 dogs. And I'm going to run the same constructor on both of them, on all of them. I don't have to. I can actually create and use this one here with, so I have a constructor that takes on the name. I'll go back to dog here. I got one that takes a name. Should fill this in here. Constructor that takes name. I got one that takes weight, one that takes age, and then I got one that takes age and weight, and then this one is all three. Because remember I added the name up here and I changed the weight to float and the age to an integer to begin with. So I've got these 3 pieces of data, and so let me see this one here. I'm going to do an age and a weight together, so I can come back over here to main, and here I can do age and a weight. So let's do Curly here. His age is make this guy 40, and the weight is make him 100 pounds. And the weight's supposed to be a float, so we'll do that. And you can see it says dog integer a comma float w. So the help system's going to help me make that. So I can run any one of the constructors, but I have to specify which constructor I want to run. This is the same as doing this. Dog D1, and then we've got 40, 100, 45. Or what we were doing earlier, new dog. So we can do it both ways, a dog, a D1, new dog, etc. and so forth. Oh, that's going to cause a problem. That's going to be declared dog D1. Oh, we already have D1. Fido. So now I got Fido in there. So if we run it, what we're going to get then is, before we run it, I have to comment out the code that's going to print out one of these dogs. My dog, first element name for the my dog is going to be element 0. Well, we ran it with the Larry, so it's going to print out Larry. Actually, before it said Larry, Curly, and Moe, like the 3 Stooges. So now we should get Larry printed to the screen. Probably going to get all this other stuff. Oh no, I didn't. I commented it out. Larry, here's Larry. So what did I get? I got 1, 2, 3, 4, 5, 6, 7, 8. I got the integer a comma float f constructor. the string constructor, then the a comma float f constructor. A comma float f constructor. What did I do? Oh, I put it up here. I've got two of these guys going on here. Here, let me make this a little bit simpler. Take out this guy. Take out pets. Let's not make any more pets here. Take out all the irrelevant stuff. Now I'm going to make a set of 3 dogs. So I'm going to have a Larry constructor, and two constructor, and another Larry constructor, name constructor. And then I'm going to print out Larry's name. So now I got better, smaller. So I got S constructor takes on the name, that's the Larry. A and F, that's the age, the age and the weight. And then I've got the string again. And then I've got this one here that says Larry on the bottom. So I'm running all 3 constructors, making 3 instances of the 3 objects, sticking them inside of an array, helps me better organize them. So then I can go, well, I want dog 0, dog 1, dog 2, dog 3. And then I can use that to better organize all these objects that I'm creating. So, did I lose anybody? I see a lot of concerned faces. Digest it. It's only the first weekend. So, the reason why I wanted to show you arrays is to make your life easier. Right, yeah, think about the array concept. We'll revisit it again, don't worry about it. I also have some boring PowerPoint lecture stuff for you on that. So, don't worry about the arrays if you don't get it at this point. So, that's your first exposure. Let's move on to something different. Unless somebody has any suggestions right now in terms of what else you want to learn regarding constructors or arrays of objects. Alright, so I'm going to end this video, even though it's only 47 minutes long, approximately. Yes? Say that one more time? Say that one more time? Ah! Let's look at constructors, destructors. Let's look at the destructor. Actually, there's one more thing. No, that's a good thought, actually. Let me show you about dynamically allocated arrays and how to get rid of arrays. So I showed you new and delete. So we have different syntax. So thank you. That was a good. I needed inspiration in terms of what to show you next. So, integer. Let's go back to your friend the pointer. Reference PTR. I don't know. I don't know. Do I have PTR in here? I don't have PTR in here. This is good. Equals new int. We're a little bit okay with that. And then if we want to get rid of this new int, we go delete PTR. And we've just deleted PTR. So we have the new int created, and then we have the new int removed. Well, what if this PTR was an array? Then we just use delete. We use a separate symbol. So if we go integer PTR2 equals, oh, let's create 3 of them, equals new integer. Not gonna work. Let's see, make sure my syntax is correct. Not gonna work. Expected PTR. Let's do this. Don't really need to allocate them. I don't have the syntax off the top of my head. I probably should. That's my bad. I have 3 pointer references. If I were to delete them after I've allocated them, then I simply, instead of doing this here, I take the same syntax. If I use the same syntax on it, I'm not going to get an error message at all. Everything should work just fine with that. But what I am going to get is the removal of just 0. It removes just the starting location. It doesn't remove the whole thing. So I've partly allocated it. Excuse me, partly deallocated it. I only got rid of, because this here represents the starting address, and this one says we have 3 of them. So we have this syntax here where you put in the opening and closing array brackets. And I hope that syntax works. It does. That's going to get rid of all 3 of these guys once it's been allocated. In this particular case, we'd have to make ptr2 0 equals new int, ptr2 3 2 1 equals new int, 2 new int 3 if we were going to do it this using this syntax. And then regardless of how we allocated it, we include the array indexes here to tell us, give me all of this stuff here. We don't actually have to put a value in there, we just tell them to do that. So when do you need a constructor, and when do you need a deconstructor, and when do you need a copy constructor? Only if you're allocating memory inside of the object. So let's mess around with person, because dog is pretty complete right now. Person's a little smaller, a little easier to manage. Inside of person, I'm going to allocate something. I'm going to create a pointer, and I'm going to make this one, let's just do, instead of a string here, let's just do a character array. I mean a character pointer. So we got here character, and yeah, let's just do that. So we're using a pointer inside. So in the in here, let's see, why do we have X in there? Now instead of this one, just take this out right here. In the default constructor, we'll assign. Oh, actually, let's do it this way. Let's do floats. Float height. There we go. Because character arrays are slightly different. So let's just allocate a piece of dynamic memory inside of a person. Because I've done this, every time I allocate this, if the object goes out of scope, I have to deallocate this, which means I'm going to need to create what's called a destructor that's going to remove this after it's been created. The constructor is going to construct it, the deconstructor is going to remove it. Do I have a constructor in here? Of course, I picked one without a constructor. Let's go ahead and put a constructor in person. I am in person.h, so I'm going to go down here and say person. So now I have a constructor. We know that the constructor has the same name, doesn't take on a data type, has the same name as the class name. The only difference between the constructor and the deconstructor is this little tilde sign right here, person. So that's the function prototype for the destructor, which says now we have one that's going to delete. So in the constructor, I'm going to make a person. So I'm going to assign a weight. Let's just write the constructor right now because I realize it doesn't exist here. Nope, it doesn't exist, which is good. I picked a nice one to work with. Person. And in here we're going to say weight. It's going to equal to 100 pounds. Then W-E-I-G-H-T, age. Do we have age in this person? What do we have in this person? Age, weight, and height. Age is equal to 21. Well, no, all of our dogs are 31, or 21, so all of our people are 21. And then I'm going to say height. But height is a pointer. So I could say height is equal to a new floats. Did I make it a floats? I think I made it a floats. So we're allocating it. Follow height. Have it equal to 12.0. See if I get lucky here. No luck. No such luck. I got void set name. Oh, I removed something, didn't I? Set. I removed the set name. Did I implement set name? Set age, set height. Let's get rid of this one. It's working with the name. I took the name out. So I removed something from it. Okay, so we got lucky. But it's only halfway there. So what I'd have to do in this particular case, if I were to finish this implementation, is I'm just going to cut and paste this actually, because the syntax is already there. The only thing different though is that this one here has a tilde in front of it. So this one here is my destructor, and in here all I'm going to do is delete height. So I'm going to go delete height. because I created height in my constructor up here, and I said I already did float pointer height. I could have done it in here, but if I do it out here, this becomes a member. Height here becomes a data member of the object. So now I can get height, remove height, stuff like that. It doesn't really affect how I'm going to use it. In fact, we'll make a person. We'll see it's just used the same way. But because that's going to be normal. The age and the weight's going to be normal. It's just this new height. And so if I delete the height, which means when the object goes out of scope, let's see what we've got here. Constructor, deconstructor of type before. Person, 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 person. Oh, let's see. I have a syntax error. Person, 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 destructor or type conversion before.
That's person.
It's I got a problem with person.
Person method should have a tilde.
No, oh yeah, you're right. You're right. You're right. You're right. I put the tilde in the wrong spot. So it's inside of person. We have person. Correct. Thank you. That's how I know you guys are paying attention at least. Oh, but I didn't create a person. Let's create a person. All right. So how do we create a person? How do we remove a person? Well, this is only going to work when we remove the person. So we'd have to create a person dynamically. The dynamic allocation would create a person. Would create a height dynamically. And then when we remove the dynamically allocated person, the destructor removes the dynamically allocated height that's inside of that person. If we create it the other way without using it, we'd have to figure out how to change the scope. So we could call a function, and the function made a new person. And then we changed from the function, and we go back to main, and then we're in a different scope. And so everything that was in the function stays in the function. It goes away, doesn't transfer. Control doesn't transfer back. So the return would close down all of that stuff and remove the person, which would cause the destructor to fire. So if you caught that, destructor fires in two particular cases. Once when the object itself is deleted. When you remove the object by using a delete on the object, or assignment of the object to another object type or something of that nature. When you're removing it, it's going to fire the destructor. Or when it loses scope. So let's just create a function. In the function, let's going to call this one here void my unnecessary function. Oh, there we go. There we go. Beautiful function out of it. No, that's too long to write. My func. How's that? My func is easier. So I'm going to call this function, and then the function is going to end. And so the scope of this, whatever I created in here, is going to go away too. What am I going to create? I'm going to go person barb. Person barb is going to allocate a person. So when barb goes away, it should be deallocated. So how am I going to do that? I don't think we're going to be able to get a return out of that. If you put a C out inside of the destructor, I'm not quite sure that's going to work. Well, did you do it already?
It's firing for all the instances.
I don't have this one. This is person. I had dog firing. Let's see. In constructor. So let's just do it this way here. C out. I had it for the dog, but I didn't have it for the person. In person constructor. And then in the destructor, I don't think that it's going to fire, but we'll see what happens. Let's do it before we delete the height, actually. The destructor, I don't think you can catch a C. I don't think you can catch output from it. But let's see. I'll have to, for next time, I'll have to come up with an example for you. Unless you guys want to come back tomorrow. No, tomorrow's a holiday. You guys don't want to see me again for another 2 or 3 weeks after this weekend, I know. I don't blame you. I don't want to see myself either. Oh, what is this? Syntax error of some sort? See out declared first use. I'll probably have to see out in person. See out IOStream. Maybe it would help if I put IOStream up here. Include IOStream. IOStream. Let's try it again. Ah, now this one works. So, oh, I have to call the function, don't I? I created the function, I just didn't call the function yet. So let's see if this actually works. Don't really need this one. Don't really need this one. See down here on the bottom, we'll go call my func. So I'm calling the function. The function is going to create a person. And then the function is going to return back. So let's see if the function actually does create the person. Oops. Oh, I deleted the memory that goes along with this one. Hold on 1 second. Huh? The destructor gets called automatically the same way as the constructor gets called. I cannot call the constructor, and I cannot call the deconstructor or destructor. I call it a deconstructor. It's really called a constructor. What did I do here? Oh, I didn't declare my func here. Hold on, let me put a function prototype. Actually, let me just put this whole thing at the top. I didn't put a function prototype in at the top. So it's so small, I'm just going to put it on the top. We lost her already. I'm surprised she hung out this long. She doesn't have to be. She's auditing. She's just coming in because she wants to learn this stuff. She's not really in the class. That's another teacher, math teacher. She's in the class because she wants to learn how to do C++. I'm surprised she stayed this long all day yesterday, most of the day today. Alright, well I should put a line return at the end so we could see both of them. We got in-person constructor, in-person deconstructor. So my theory was, I was incorrect. I was doubting whether or not the cout would actually work in a destructor because, you know, it depends on the timing. Have you left already? But I think I did it before I did the delete, so if you do it right at the beginning. So now we can see when a destructor works. And what did the destructor do? Well, in the constructor, I created that memory. So what if I created the memory somewhere else? I can still delete it. It doesn't matter where I create it. It doesn't have to be only in the constructor. If I come back over here, let's create a person out there with, oh, I don't have any constructors in this one. All right, let me make another constructor. Actually, let's not do that. Let's just set the weight. I'll set a weight, or set a height. So let me add another one in here. This function here is going to be called integer. Oh, here. We'll just, in the set weight, I'm going to change it so it sets the height and the weight. So in here, the same code that I put out here for, copy it. Well, technically I don't have to allocate it, it's already allocated. Instead I can just do this. Height is going to be equal to 55. So they're 55 feet tall. And I can still actually get height. Let's see, let's get height actually. What am I going to return? I'm not going to return a pointer out of that. I'm just going to return the value that I got height set at. But height's a pointer. So I just return follow height. And I'm going to get the value that's at height. So let me write that one because that one might help you understand as well. I'll put it underneath here. So let's just change this one to set height. And we'll just, height's going to be equal to 55. So out in the person, I'm going to change this method that I just did here to get height, and then I'm going to set height down here. So I got to set height and I got to get height. Hopefully I did this correctly. Normally I would actually do this to it. I don't know why I did it this way. I put the setters and the getters together, that way I know where to find them in the same order. So get age, set age, get height, set height. And then when I implement it, because this is pretty small, but when you implement it, it can get kind of large, and you're like, where is everything? So get height, because I took the weight out, remember? So get height is going to return follow height. Is it capital? No, it's lower. Ooh, follow, H-E-I-G-H-T. Is that spelled right? Hopefully it is. Follow height, have it equal to that. Follow height, return follow height. And then on so the set height is following height, having it equal to 55.0. On the get height, it's just returning the follow the height. So I'm putting this asterisk in here because I'm dereferencing a height. This height is a allocated memory. It's a pointer, so I have to dereference it. I'm going to go ahead and fix my here. I'm going to put some end line at the end so it shows up on two different lines. Makes it look a little easier for those people who might be downloading this later. Of course, I didn't document too much. Okay, good. Let's make sure I didn't get any typos in here as well. No typos. Warning, conversion from integer to float. Because I've got integer here, so let's change this one to float. And I might have to change it back out in the C++ file here. This is a float. Because remember, weight was an integer, and I changed it and I made, I don't know why, but I made height a float value. Weight, it was an integer. Weight probably should have been a double or something, or a float. So. Unless people weigh exactly so many pounds. These people do. So integer get weight, get age, avoid set age. So now I think I might have my set height. Well, it's not really taking a height. It's taking a float. Float W. So set height, I'm going to say float H in here. So let me correct my set height void method out here. Set height. This is also going to, because I just saw that as a problem as well. Set height, well, it's going to be equal to F. So I run the set height. I give it a height to set it to. Follows the height, has it equal to that height. When I return the height, it's a float. It's going to return the height by following the height. So now all I have to do is change main, so it does something, sets the height, and stuff like that. So let's go back into, it's going to be in that main function here. So we got barb, person barb. So we'll do a double whammy. We'll create, well, I might regret this. I'm going to do a double whammy. I'm going to delete barb at the end of this function call too. If I delete barb, and barb's got a destructor inside her, it's, yeah, I know, but the destructor should delete the height. See, I can do a double. So when I've allocated the object this way, I've allocated the memory for it. The destructor is only removing what's inside of the object. The height is inside of the object. This object here is not going to get garbage collected automatically. But it will, that's the interesting thing. I think it will because it's in a function and it's stacked. But I'm taking a, this might not actually compile. Let me just make sure it actually works this way. No, it will work. What I've done is I've taken a statically allocated function call, dynamically allocated an object inside of it. I'll delete the object. But I'm curious, though, to see if the destructor is going to fire inside of it. It should. All of it should fire. But let's just see what happens with this. So I'm going to go barb. And then I'm going to use the arrow because I'm going to set it. But I have to follow barb, actually. So I'm going to go follow barb. Set the, run the set height method. I'm going to send the method, let's say, so I'm going to remember 777. The height's going to be 7. Oh, it's going to be a float dot 77. There we go. Here we'll do 77.77. And then, well, let's just print it out. cout. This is all inside of the method that we're running my func. Cout barb's height is, I have probably misspelled everything around here. Follow barb. Dot. So what I really want to do is the dot here. If this were, I'll show you what happens here. If this were just a regular non-allocated, I wouldn't have to use a dot. I just go like this and go, well, what do I want to do here? I want to get weight. Where's my height? Get height. That's going to give me an error. That's going to give me an error message because I need to do this with it. And that's going to give me an error message because I need to do this with it. I need to follow barb because barb's a pointer. And, excuse me, get height is what I want to run here. Get height because set height is up here. Set height's taking on a height and it's going to set it for the object. I'll just make sure before I'm going to have problems here. Void value not ignored as it ought to be. Let's take a look at set height for a second here. That's a warning. That's interesting. That should be invalid type argument in unit array. Yeah. Okay, let's take a look here. Get height is float. Set height is void. Set height person. Get height. Save all. Update it. Void value not ignored as it ought to be. We're not returning a value. Follow barb set height to new. Might be losing my mind here. I believe I am. I don't have to follow it if I'm using the. I don't have to follow it if I'm using the directional. Let's just see if it works. Yep, it does work. All right, so I'm sorry. I'm saying I'm not leading by a good example here because I'm losing my mind. So I'm going too far into this for me personally. So you don't have to follow it if you're going to use. Okay, barb is representing the object. It's a new barb. It's a person. It's already in the memory. If you were doing this, this is not going to work, but this is the same. The dot notation is to follow and then use the dot as a reference from an identifier, and this is no longer using it as an identifier. That's not going to work. That's not going to work. So instead, we remove the reference, but we treat it like a reference here. So the reference symbol inside is the equivalent to following, but we don't have to follow. We're just going to the object, and then inside of the object, this is how we're referencing it inside of the object. The problem is we have like a two-level layer of abstraction. We have the outer object, and then we have all those little things inside, the age, the height, the weight. They're inside of that object. So we're referencing the object as the object, so we're going to the memory location. So if we say barb, barb's some hexadecimal value. If I printed barb out to the screen, I'm going to see hexadecimal. I don't have to follow barb. If I follow barb, I'm getting something. It's not void. It's giving me something else. It's giving me all of the information on there. And technically, if you followed barb, you'd be able to use a dot here because you would be able to resolve where each one of the individual items was, but you can't. It doesn't work, although it should logically work in the language. It doesn't work. Instead, they take and they say, well, okay, remove the dereference and use this arrow stuff, which is inconsistent again, because everything else you use a dot for everything except for pointers, and you have to use this arrow thing. So Anyway, back to the example now that I've totally, I'm losing my mind towards the end of the day, so I'm now that I've totally confused everybody in the room. Here's the function again, and in the function we're creating an instance of Barb. I'm going to remove, so let me finish this here. I'm going to delete Barb. So the idea here is that because I've created Barb, and Barb's a new person, and I've used new, once I leave this, I'm going to leave the reference to Barb, which means the object itself gets deleted. This should be a double whammy. That should be unnecessary, which is kind of interesting. We'll see what happens. I'm kind of curious to see if this will actually trigger it twice or whether it be ignored or give me an error. Well, it didn't give me an error, so I'm going to run it and see what happens here. I got in-person constructor, Barb height is this, in-person destructor. So what would happen then? I don't think I'm going to see a difference if I take this delete out. I'm going to put a line return over here so I can sort of see. So I'm going to take out the delete Barb, which I believe is unnecessary because it's already going to be removed because it's static. It's in a statically allocated function, but I'm dynamically allocating it. You'd think it would create garbage, but let's see. It probably does create garbage, actually. No, it doesn't. It does create garbage. I actually had to put the delete Barb in there to get rid of it. So the first time I did it, I didn't do it at all, though. The first time I did it, so let me put both of them in here so you can kind of sort of see what I'm looking at. Here, I removed the delete Barb. I dynamically allocated the object. I stuck it on the heap. It stayed on the heap. Stayed on the heap when the function ended. In order for me to get it off the heap, I have to do this. I have to delete it off the heap. So now when I run it, close. Oh, no close, I'll cancel. Close this one. No, don't save that one. Okay. Main. Now when I run it, the delete is deleting it off the heap. It's running the destructor. So I've got in constructor, height is equal to 777, in-person destructor. So I'm deleting it manually. If I leave this out, I don't get the destructor, which means the object is still on the heap. But if I statically allocate it, let me make another function here. This one's pretty easy. I just cut and paste this one, but I go back to the old way of doing it. Forget about all this stuff here and just create person. Actually, I can create person Barb again and just create the person Barb and then call this one function 2. So I'll run one and then run the other one right underneath it. So I got both of them running. One of them is a statically allocated object, and this one is a dynamically allocated object. So I got one statically allocated, not using new. Compiler's going to take care of it. It's on my stack entries. But the object itself, because it's statically allocated, is going to be removed by itself, by the static runtime, and then the destructor inside of the object is going to fire. So let me make sure we can see which one's here. So I'm going to go see out inside of static 1. Yep. So in-person constructor. So we created this one up here because we ran this one first. Maybe a little bit bigger so you can see what I'm looking at here. In-person constructor, Barb's height is 77.77. In-person destructor, got rid of it. Got rid of it because of delete. If I take delete out, I'm not going to get rid of it. It's going to be garbage left on the stack. But this one I didn't have to use delete with because this one was created by a regular person Barb. So inside of the static one, this is that line of code there, got printed out. So okay, I'm in there now. In-person constructor, in-person deconstructor. So the deconstructor fired automatically for me with no delete over here. So when you use new, you got to use delete. Long story short. I'll post this one with this lecture at the end, yes, so you don't have to worry. I'm gonna leave it as is too. I'm trying to document it as I'm writing it, but I'm doing a lousy job with that. So, and I'm trying to make sure when at the end I don't change it so it doesn't compile correctly. But you have to uncomment some of this other stuff. But I removed. I may have removed something as well. You can always watch the video too, and you can see what I did. But did I lose anybody? Does anyone want to admit that? Okay, now I believe it's time for a bio break. Alright, so let's take a bio break, and I'll make sure I label this one. Let me save this one here, zip it up along so I can post it with the video so we know what's going on. I'll call this one number 4, I think. This is lecture example number 4. Alright, bio break for like 10 or 15, and then we'll go into our last topic for today, which is going to be inheritance. Alright.